Welcome back to Chapter 2, and we're moving on into division. So there's a couple things I want to discuss real quick before we actually start doing some problems. One of them is, remember back to Chapter 1, and we were dividing like bases. So whenever we're dividing, we have to make sure that we subtract the exponents. So we want to make sure that we do that. The other thing is, I want you to think about how you learn to divide. And I know we're in a time where different people are coming up with different ways to divide. I'm going to just go back to the old algorithm that was used for division, and that's the one I'm going to practice right now because we're going to use it in a little bit. So if we want to do something like divide 2 into 4, 7, 6, 3, 6. I just made up a number. So we would take 2 and we would put it into the first one as many times as we could. 2 goes into 2. 2 goes into 4 2 times. 2 times 2 is 4. Then we would subtract, see what was left, and bring down the next number. So then we would say, okay, how many times does 2 go into 7? 2, 4, 6. It goes in 3 times. 3 times 2 is 6. We'd subtract. We have 1. Bring down the next term. 2 goes into 16 8 times. 8 times 2 is 16. Subtract. This is what's left. Bring down the next term. So we just keep doing this process over and over again until we get to where we brought down the last term. And I made up one that did not have a remainder because 2 times 8 is 16, which leaves us with nothing. This is the same type of process we're going to do when we get to dividing by more than simply a monomial. We are going to start by doing a monomial and then we'll go on. So one of the ways I want to show you is a visual way of understanding what's going on before we actually just use the rules. So in this first one, I'm taking 7 w to the third x y to the fifth z, and I'm dividing it by 14 w x to the fourth y to the third z. So I want to do this visually. So we have 7, we have 3 w's, we have 1 x. This means I have 3 y's. That's actually a 5. So I have 5 y's, 2, 3, 4, 5. And I have a single z. So that's my numerator. Now I'm going to try and draw a line, and then I'm going to do this bottom. 14 I know is 2 times 7. So I'm writing it as prime numbers. I have a single w. I have 4 x's, 3, 4. I have 3 y's, 1, 2, 3, and I have a single z. So what I see is I have terms both on top and the bottom. And if we think about whenever you have a number, or like 2 over 2, 10 over 10, a billion over a billion, it always cancels out and just becomes the number 1. That still holds true when you have multiple parts. So 7 over 7 just becomes 1. W over W just becomes 1. X over X just becomes 1. Y over Y, Y over Y, Y over Y, and Z over Z. So everything I've crossed out is just the number 1, and multiplication, it doesn't change anything. So now what I'm going to do is I'm going to see what I have left. So on the top, I see I have 2 w's, so that's w squared, and I have 2 y's, so that's y squared, and I don't have anything else. On the bottom I have a 2, I have 3 x's, and that's it. So this is my answer. I have done the division, and literally all I've done is canceled out like terms. So that's one way of thinking about how to do this process. I'll show you the other way on example 2, and then you can decide which way works better for you. So on this one, I'm going to start by putting it in this fraction form. 46 a to the third, b to the fourth, c to the negative 3, over negative 2, a to the negative 3, b, c to the third. So this time I'm going to use the rule that we used last chapter up here, that if I'm dividing, I'm going to subtract exponents. So first I'm going to look at the number. So I've got 46, and I'm going to go ahead and divide that by -2, and I get -23. Now I'm going to look at the exponents. So I have a 3, and I'm dividing, so I'm subtracting the bottom one, which is -3. Now I'm going to do the b's. The top one's 4, I'm subtracting, this is a 1. Then I'm going to do the c's. Top one is -3, I'm always subtracting, the bottom one is 3. So this is if I want to use that rule. So now if I put this together, I still have -23, a negative and a negative in this case add, so it's 3 plus 3. So I have a to the 6th. I have 4 minus 1, that's 3. -3 minus 3 is -6. Now, as you recall in Chapter 1, we don't like to have negative exponents. It's not considered proper. So we're going to rewrite this as -23, a to the 6th, b to the 3rd, because those both already had positive exponents. Since my c has a negative exponent, it's going to move to the bottom and become positive. So this would be the proper form answer. Now, as we move on, I'm going to go ahead and use the example 2 rule to do this problem. If at any point you want me to do something using the example 1, send me a quick email and I will do that for you and send it to you. So on example 3, now notice this time it's a binomial that we're dividing. So I'm going to start still by putting this in the top. 5r to the 3rd st to the 4th minus 10r s to the 4th. And I'm dividing by -5 rst to the 3rd. So if you remember back to multiplication, when we were doing the distributive property and we got larger terms, we simply had to do it more than one time. That is the same in division. So what this is asking me to do is really to do 2 different division problems. One with the 5rs term and one with the -10rs term. So I'm going to separate them out so I can visually see that. So it's 5r to the 3rd st to the 4th being divided by -5 rst to the 3rd. Now the next one, and I'm going to go ahead and put a plus here, and it's not that I'm changing anything, it just helps me remember that the negative goes with the 10. So there's my -10 rs to the 4th over the -5 rst to the 3rd. Now the plus does 2 things. One, it helps me remember that I'm not multiplying these terms, that I'm actually just combining them with simple addition, or I can think of it as subtraction. And 2, it makes sure that when I'm dealing with my signs in this division, I don't forget them. So I'm going to come over here and I'll do the numbers first. 5 divided by -5 is -1. I have r to the 3rd, r to the 1st, so it's 3 minus 1. 3 minus 1 is 2. I have s to the 1st, s to the 1st. 1 minus 1 is 0, so I have no s's. Those are essentially canceling like they did on the first one. Now I have t to the 4th and t to the 3rd. 4 minus 3 is 1, so I have t to the 1st left. Again, the 1 in the front and the 1 in the exponent aren't needed. So I'm going to look at the second term. I have a -10 being divided by -5. A negative divided by a negative is a positive. 10 divided by 5 is 2. So I now have a positive 2. r to the 1st, r to the 1st. 1 minus 1 is 0, so I have no r's left. S to the 4th, s to the 3rd. So I do have 3 s's left. Now, if I notice on here that I don't have any t's on the top, so what that is it's saying t to the 0 because I didn't have any. Now I can just do 0 minus 3, but I'm going to end up with a negative exponent, which I know I can't have. So since I have t's on the bottom and none on the top, I'm just going to leave them on the bottom because there's really nothing that I have to work with. So this ends up being my answer. I just did the division twice. On the next example, really I'm just doing it more than twice. I'm doing it 1, 2, 3, 4 times. Same process. So we're going to start by pulling them apart. 8xy being divided by 4xy. Again, I'm going to do the plus so I keep my signs with the number. negative 4xy squared over 4xy plus 10x squared y over 4xy plus negative, staying with the 14, x squared y squared over 4xy. So I have 8 divided by 4. It does go in there whole time, so it's the number 2, not number 4. Let's get rid of that. Try that again. So 8 divided by 4 is 2. I have x to the first and x to the first. 1 minus 1 means there's no x's. Y to the first, y to the first. 1 minus 1 is no y. So the only thing left in the first term is a 2. Now I have a negative 4 being divided by a negative 4. That is a negative 1. X to the first, 1 minus 1 is 0, no x's. Y to the second, y to the first, 2 minus 1, I have a single y left. Now when I go to do the next one, what I'm noticing is it's not going to go in an equal amount of times. So I have 10 over 4. Since 4 won't go into 10, all you can do is reduce. 10 is divisible by 2, and so is 4. So I'm going to leave it in a fraction, and I'm going to have 5 over 2. I did 10 divided by 2 is 5, 4 divided by 2 is 2. 5 halves does not reduce, so they're staying. Now I have x to the second and x to the first. 2 minus 1 is simply x. I can remember that the x goes on the top because I had more x's on the top. Y to the first, 1 minus 1 is 0, so I have no y's left. So the third term is 5x over 2. Going to the next one, again this doesn't go in evenly. Negative 14 divided by 4, it's going to be a negative. 14 and 4 are both even, so they can be divided by 2. 14 divided by 2 is 7. 4 divided by 2 is 2. X to the second, x to the first. 2 minus 1 is 1. Y to the second, y to the first. 2 minus 1 is 1. So both the third term and the fourth term ended up being a fraction because they didn't go in evenly. Now if you really have kind of a love-hate relationship with fractions, you could change the 5 halves to 2.5 and the 7 halves to 3.5. It would still be considered the same thing. Okay, so far in the first 4 terms, everything that we've divided by has been a monomial. As you look at 5 here, now we're dividing by a binomial. And so this is why I wanted to go over this idea of what we called long division. That's what the algorithm used to be called, because that's the process we're going to do. We're going to figure out how many times it goes in, then we're going to put down what that used and subtract, and then bring down the next term. Okay, so here's how it gets set up. So it looks just like long division. It's 2x plus 1, because that's what we're dividing by. And then I'm going to put what you're dividing into on the front. Now, this is not in proper order. When you put them inside here, they need to go highest exponent to lowest, and you have to include all of them. So I have an x to the fourth, that's the highest one, so I'm going to write that one first. I notice there's no x cubes, so what I do is I put a 0 here as a placeholder. It'd be the same as if you had the number 8043. That 0 is a placeholder, so you'd want to make sure you keep it there. So I'm going to go ahead and get rid of that. I don't need it. So now I go to the squares, and I do have some squares, so plus 6x squared, then my single, so negative 4x, and then my constant. So I just put them in order from highest exponent down to lowest exponent. So now what we're going to do is we have to see how many times does 2x go into 8x to the fourth. One of the things that I've found seems to help people is when you're doing this, how many times does it go into, is do little mini division problems over on the side. So really I have 8x to the fourth, and I'm dividing it by 2x. So I'm saying how many times does the 2x go into this. 8 divided by 2 is 4. 4 minus 1 is 3. So 2x goes into 8x to the fourth 4x cubed times. The 4x cubed is what goes on the top. Now if I multiply, 4 times 2 is 8, x to the third times x to the first is x to the fourth. Now if we look back to our long division algorithm, once we get this number down here on the bottom, we are subtracting. That's the key here. So I am going to subtract this. But the part that's different is this is a binomial here that I'm multiplying by, not a monomial. So not only do I have to multiply the 4x cubed times the 2x, I have to multiply the 4x cubed times the 1. So 4x cubed times 1 is 4x cubed. Now remember, you're subtracting, but you don't just subtract the first term, you have to subtract the second term as well. And this is the confusing part. So I have 0 minus 4, that's negative 4x cubed, and I bring down the next term. Okay, so now I'm trying to take 2x into the next, and I only look at the beginning part, so I'm only going to negative 4x cubed. Negative 4 divided by 2 is negative 2. X to the third divided by x to the first is x to the second. So this is what goes up here on top. So I'm essentially making a list of the answer pieces up here on top. Negative 2 times 2 is negative 4. X to the second times x to the first is x to the third. Now I also have to do it times the 1. So negative 2x squared times 1 is negative 2x squared. Now remember, you are subtracting. When you subtract negatives, they change to positives. So negative 4x cubed plus 4x cubed, that's going to cancel. Nothing's left. 6x squared plus 2x squared is now 8x squared. Bring down the next term. So now I'm pulling into 8x squared. It's always the first term and after I've done the putting it together. So I'm going to do 8x squared. Notice these bottoms are always 2x because that's what's in the front. 8 divided by 2 is 4. X to the second divided by x to the first, 2 minus 1 gives me 1. Notice these are going down sequentially, and they should. So this 4x should be the next one up on top. 4x times 2x is 8x squared. These always match if you did it right. 4x times 1 is 4x. Now I need to subtract. This goes away. Negative 4x minus 4x is negative 8x. Bring down the next term. So last one. Negative 8x is in the front. I'm dividing it by 2x. Negative 8 divided by 2 is negative 4. X to the first divided by x to the first, 1 minus 1 is no x's. So the negative 4 is my last one. Negative 4 times 2x is negative 8x. Negative 4 times 1 is negative 4. I'm subtracting, which makes negatives turn into positives. I have negative 8x and positive 8x, so that's gone. I have negative 4 and positive 4, so that's gone. And so I have nothing left to bring down. So my answer is 4x cubed minus 2x squared plus 4x minus 4. Long process, so make sure you take your time and do one step at a time. So the next one that I have here, and actually there's 2 left, and I've left lots of room. They might look scarier because they have bigger exponents, but the process is exactly the same. So the key, remember, is to take your time. So the by part always goes on the outside, so it's 4x squared plus 2. Inside's going to go in order, so pay attention. Looks like the 5 is my highest exponent, so it's 4x to the 5th. I'm not seeing any x to the 4ths, so I'm going to put a 0 there, just to keep that placeholder. See an x cubed and an x squared. Don't see an x to the first, so I'm going to need another placeholder, and then my constant. Okay, so the 4x to the 5th is going to be the first thing that I'm going to work with. I'm dividing it by the first term on the outside. 4 divided by 4 is 1. X to the 5th divided by x to the second. 5 minus 2 gives me x to the third. So the first thing I'm going to have in my answer is x to the third. X to the third times 4x squared, 4x to the fifth. Now here's where it gets a little tricky. X cubed times 2 is 2x cubed. That's not the next term. I want to stack them. So I'm going to put my x cubed, what I got from x cubed times 2, underneath my other x cubed term. Now I'm subtracting these, so I'm going to make sure I have subtraction signs. 4x to the fifth minus 4x to the fifth is gone. I don't have any x fourths, which is fine. I just wanted to make sure I didn't need them. Negative 2x cubed minus 2x cubed is negative 4x cubed, and I'm going to bring down my next term. So now I'm working with negative 4x to the third. I'm dividing by my front, which is 4x squared. Negative 4 divided by negative 4 is negative 1. I'm going to divide x to the third by x to the second, so 3 minus 2 is x to the first. That's my next term on top. Negative 1x times 4x squared is negative 4x cubed. Negative 1x times 2, 2 times negative 1 is negative 2, and it'd be x. Now I should not have written that there, so that's a good example of what happens. If I tried to combine these, I can't combine an x squared and an x. So instead what I'm going to do is grab my eraser and erase this section because it's in the wrong spot. I actually need to go ahead and bring down my 0x because when I multiply negative 1x times 2, I get negative 2x, and I want to be able to stack like terms. So now I'm going to subtract these negatives, which are going to turn them into positives. My negative 4x cubed plus 4x cubed is gone. I don't have anything to add my 6x squared yet left, so I'm just going to bring it down. I have 0x plus 2x, which is 2x. I'm going to go ahead and drop this negative 8 and see if I need it. So now I have 6x squared that I'm working with, and I'm dividing it by my 4x squared. 6 divided by 4 is not a whole number. It's okay, we can still work with it. It does reduce to 3 halves. Again, if that really is not your cup of tea, just change it to 1.5. X squared divided by x squared, 2 minus 2 is 0, so I have no x's. So I'm now going to go ahead and the 3 halves is the next part of my answer. So 3 halves times 4. 4 times 3 is 12. 12 divided by 2 is 6. So it is 6x squared. Now I'm going to do 3 halves times 2. 2 times 3 is 6. 6 divided by 2 is 3. So that's just the whole number 3. So I'm going to move it over. I'm subtracting. So I have 2, this is gone. I have 2x minus nothing, so it's still 2x. Negative 8 and negative 3 is negative 11. So now what's happening on this one is I actually have what's called a remainder. I can't take 4x squared into 2x because the exponent on this x down here is lower than the one what I'm dividing by. So I'm done. So this is my remainder. There's 2 ways you can do it. You could just do r and do 2x minus 11. And that just says it's a remainder. That's one option. The other option, and I'm going to go ahead and erase, and you can do which one you like. The other option is what's more formal. You take the 2x minus 11 and you put it in the numerator, and then you put what you were dividing by in the denominator. So what you're doing is you're making a fancy fraction. Leftover goes on top. What you were dividing by goes on the bottom. You can tell that it's now a remainder or some leftover sections. So this is the answer. Okay, let's try this last one down here. So I have both x to the 6th on these. I just have this one's got an x and this one's got a y. So one's not higher than the other. So we're just going to do them alphabetically. And you can see in the next one that you're dividing by, those are both x squareds as well. So we're going to go ahead and do, and we're not going to fill anything, we're just going to see what happens. So I have 3x squared minus 2y squared. We're going to take that into 27x to the 6th minus 8y to the 6th. So let's see what happens here. So my first term is the 27x to the 6th on the inside. I'm dividing by the 3x squared. 27 divided by 3 is 9. X to the 6th divided by x to the 2nd is x to the 4th. So that's my first top. So 9x to the 4th times 3x squared. 9 times 3 is my 27. 4 plus 2 is x to the 6th. Now when I go to do this next multiplication, what I'm already noticing is I have x's and y's. So my answer is going to have both. This does not have that. So I'm going to just slide over. 9 times negative 2 is negative 18. X to the 4th and y to the 2nd, they're just going to tag along together. So this is what it ended up with. And I don't have any of those, and I wouldn't think of adding that in. So that's okay. We just know that we don't have any to put it with. Now I'm subtracting, which is going to change this negative to a positive. This is out. I'm going to go ahead and bring this down even though I don't have anything to match it up with. And then I'm going to go ahead here and bring this down. Now the way it's written here, I definitely don't like because I have an x to the 4th and here I don't have any x's, but I know I'm dividing by x's. So really I need to move this around. And if this happens, that's okay. So don't erase anything you have unless you want, but I want to show this a little bit differently. Let's instead move that negative 8y to the 6th down on the end. And remember when I multiplied, I got negative 18x to the 4th, y to the 2nd, and I subtracted, which made it become a positive. So now I'm going to keep my x terms to the left of my y terms. This is going to work much better. So what we've just learned is we want to make sure that my y's stay to the right of my x terms. So just keep y's after x's, x's before, just like in the alphabet. So we're going to take my next term, 18, x to the 4th, y to the 2nd. We're going to divide it by what I'm dividing by, 3x squared. Remember, it always stays the same. 18 divided by 3 is 6. X to the 4th divided by x squared, 4 minus 2 is 2. I don't have any y's, so now I'm going to tag along some y's. This is going to help because I need to get some y's into my problem. So I have a positive 6x squared y squared. 6 times 3 is 18. X squared and x squared is x to the 4th. Y squared and no y's is y squared. We're going to do the next one. 6 times negative 2 is negative 12. X squared and no x's is x squared. Y squared and y squared is y to the 4th. I'm going to subtract, so that goes there. This negative becomes a positive when I subtract. These are out because they're identical. These have nothing in common. So let's make sure we write our x term first, and then the one without the x term. Okay, we're going to do it again. So this is my starting point. 12x squared y to the 4th. We're going to divide it by this front, 3x squared. 12 divided by 3 is 4. X squared divided by x squared, 2 minus 2 is 0. It's out. I have y to the 4th left. It's all that's left, so I'm going to have a plus 4 y to the 4th on top. 4 times 3 is 12. Y to the 4th and x to the 2nd, they're just going to tag along together. 4 times negative 2 is negative 8. Y to the 4th, y to the 2nd is y to the 6th. I'm subtracting a negative, it turns to a positive. These are like terms, they're going to cancel. And these also are like terms. Negative 8 plus 8 makes those cancel, leaving no remainder. So this is my answer. So we had a little hiccup and we had to back up. So remember that what we learned was we have to make sure that our x's come before our y's, and then we can always keep it that way until we get down to the end. So that is division. Again, if you get stuck along the way, please send me a note and I will try and get right back to you with some help. Thank you and have a great day.